this using the shell command. First, notice how I've added a few fillet features to the extrusion to refine its shape. This is one of those situations where fillets are essential to the part's design, and therefore cannot be applied later. I'll show you what would happen if they were applied later shortly. The shell tool basically hollows a part out, leaving the faces you select open while creating thin-walled features for the remaining faces. You can also opt to keep all faces closed, creating a hollow model. You can shell a model using multiple thicknesses as well. When I activate the command, I'm presented with a few options. I can define the wall thickness, select faces to remove, and choose to shell the part inward or outward. I'll go ahead and check Show Preview to get a better view of my changes. I want the walls for the bin to be 10 millimeters with an open top. Now before I click OK, let's say I wanted the bottom of the bin to be thicker than the rest of the part. I could achieve this by selecting the bottom face for the multi-thickness option and then define a new value. Although in this case, I'm just looking to create a constant thickness shell, so I'll go ahead and accept the single thickness definitions. Now remember how I said the fillets created earlier could not be added later in the modeling process for this example? This is because all SOLIDWORKS features are parametric, meaning that they share dependencies with one another. Look what happens when I reposition the shell feature in between the fillets. The fillet interferes with the shell, creating geometry that is unmanufacturable. This is because the shell is dependent on the faces created by the fillets to form correctly. This functionality is the basis for all SOLIDWORKS modeling and must be considered when forming your design intent. In the next lesson, we'll continue adding to our bin model by creating